Alright guys, IB year 2. We're going to talk about histograms today. Histograms, guys, as you can read here, has a lot of people I think like a histogram, just a bar graph. And yes, they very much are just showing a frequency of a particular group. But when we talk about bar graphs, we think that every one of our intervals are exactly the same. And so when we talk about a histogram, though, is that it's used for continuous data. So therefore, some groups can be a little bit bigger than others. They may not take an actual value at something. It might just be a range instead. So they're not, oh, there's 5 people at 5 foot tall. Now we might be talking about, hey, what about all the people between 5 feet and 5'6"? So 5.5 feet. And now you're having an interval, you have a continuous range in there because people can be 5.05 feet. So that's why they use the different things there, and that it's on a continuous interval of real numbers, and it's over the entire group that it corresponds. So it can be of the same type of frequency, group data, things like that, and it can be on unequal size. So the one we have here, though, is if you notice that our groups are actually the same size, but it is over a range. And so what we need to do is we need to make a histogram. So we're given a grouped data with a frequency. So on the bottom, we're going to make that. Now, if you're looking at our data here, there actually seems to be a little bit of a layover, because this says from 40 to 49, 50 to 59, 60. So there's actually a small jump between 49 and 50. So we're actually going to let our intervals go from 39.5 to 49.5. 49.5 to 59.5. And as you can see, the biggest frequency of the group is 18. So if I were to go and make my histogram here, on my y-axis, I think I'm going to go up by 5s. Okay, and over here, I'm going to put a small break on here, and I will start at 40, 50, 60, 70, 80, so 50, 60, 70, 80, and I think I have to go all the way up to 89, so 90. And so when I go to make my bars on here, I'm going to then say, hey, that first group goes up to 12. I'm going to try to start just on the other side and go just to the inside, which would represent 49.5. This one's going to go up to the 18 mark, and notice that they will run into each other at this point because you're starting and stopping at the halves. And so 6, oops, that one's a little off, not the easiest to do. 6, 0, so nothing, and then 1. And therefore, there is my histogram. So that is how you do histograms. In essence, to save time, I am also going to do 16E-F here, which is the constant changes to data. And so what we're going to deal here is the fact that what happens if I have a large set of numbers and I add 2 to everything, or subtract 5 from every one of those numbers. What happens to the average, the mean, the mode, the median, the standard deviation, all of those things? What happens if I said, hey, I'm going to double every single one of those numbers? What would happen to those same things? Does a range change? Does a max number change? Minimum number change? All of that. And so we're going to go through here, and you don't have to redo everything. So if you are given the average of a number, now we can actually do something with that average if we know that we're doubling everything. So I'm going to go right to the key points here, and it says that if you increase or decrease every data item by a value of x, all measures of center of data will also increase. Okay, so what does that mean? So that means that the mean, median, mode are all go up by that value or go down by that value. So taking a point, if we take the three numbers from the above, if I wanted to find the average or the mean, I'm not going to sit there and I don't have to add them all up. Look at the only difference between these numbers. It's a 8, a 9, and a 5 at the end. All the other numbers are different, or the same, I meant. So 8 plus 9 plus 5, it'd be the same average, just added with the 135,400 that each one of them has along with it. And so what they did there is they added 8, 9, and 4, took the average and got 7, and said, hey, guess what? Add that same number back on after they took it off, and you end up with 135,407, which is the average. Because if I add 135,400 to all of my numbers, the average goes up by that much. My new middle number will be added to that number by whatever it goes up by. And the mode, the one that happens most often, will still happen most often just because it adds 2 to it, or subtracted 2. Okay, now adding the same quantity to every data item does not change how the spread is. So therefore, your interquartile range. So the interquartile range between numbers doesn't make a difference. So remember that when we found interquartile range, we were talking about more of that box and whisker thing, right? So if this whole entire group gets shifted to the left or to the right, it still has the same range, number 1, maximum number minus the minimum number, but it also then has interquartile. Quarter 3 and quarter 1 will be adjusted at the same rate, therefore it will not change. That means standard deviation doesn't change when you're adding. Now, if you read the last group on here, it says that if you increase or decrease every data by this value of x, all the measures of spread in the data will remain unchanged. That's what it says. So it does not change. Moving on. But what happens if you start to multiply? Instead of adding or subtracting, we multiply. Now, here's an interesting thing, is that if you multiply or divide by every data item by a value of x, all the measures of center of data will also be multiplied by x. So if you multiply all your data by 2, your average goes up by 2. Your range goes up by, your mode goes up by 2, and your mean, median, mode. So all of them go up by 2. Now, the other thing is about here is that actually, if you multiply or divide every data point by value x, all direct measures of spread also get multiplied by 2. So therefore, your range gets twice as big because your biggest number and your smallest number can be bigger. Your standard deviation will also change. Since standard deviation, I guess it says there, it will follow that the variance would be the square of whatever x is. So that's kind of big here, guys, to read. So if your standard deviation is getting twice as big, that means your variance is actually getting 2 squared, which is 4 times as large. So that's what you're going to have to take in consideration when you do your problems. So it says that a taxi driver records a distance traveled in kilometers. The cost of each journey was given $4 plus $3 per kilometer traveled. On one particular day, the average distance traveled was 2.9 kilometers, with a standard deviation of 1.1. Find the mean and standard deviation of the cost on that day. So, if it wants you to write your equation, obviously, if it's given that there's $4 initial cost, and that is $3 per kilometer, then the 3D plus 4 seems to be the right for the cost equation. Now, it's asking us, or say that on a particular day, the average distance traveled was 2.9 kilometers with a standard deviation of 1.1. So what they did here is they said the mean is transformed in the same way as the individual value of the data set. So what they're saying is that the D average will produce the C average. Remember, D bar or X bar is average. So they're saying that the average for distance will give us the average for cost. They put in the average distance, which is 2.9, happens to be into the problem, and it gives us a $12.70 is our average cost. And then it says, and the standard deviation, the cost for that day, the standard deviation is only affected by the multiplication. So as you can see, is that the original equation, you have 3 times the distance, and then you have 4. So 4 does not change your standard deviation, but 3 does. And so 3 times 1.1, the difference that it could happen on any given day, up to an extra 1.1 kilometers or down at 1.1 kilometers, you could have a change then in money-wise of $3.3 up or $3.3 down. Because remember, adding 4, subtracting 4, things like that do not change your standard deviation. So the 3 is the one that implies that you're changing or adding or subtracting to the value of the money. That is part F. So now you guys can do part E and part F. Have a great day.